Hello everyone, welcome to Code Crafters Lab. So today we are going to see another problem from Basic Maths from TUF Plus, which is palindrome number. So here we are given with the number integer n, and what we want to do, you need to check whether the number is palindrome number or not. Return true if it's palindrome, otherwise return false. So what is palindrome? Palindrome is a number which reads the same both left to right and right to left. So let's consider this example where input is 121, right? And if we reverse it, it is also 121. If we reverse it, it is also 121. That means it is a palindrome number. So that's why output should be true. Here it is 123. So if you reverse 123, it will be 321, which is not similar to 123. So that's why we will return false, as it's not a palindrome number. So here 101. So what will be the reverse number? 101. That means it's a palindrome. So we will return true. So yeah, this is correct. So similar way we have done previously one example where we have reversed the number. So here let's say if we want to identify whether a number is palindrome or not. So first thing what we will do, we will, let's say n is equal to 1 2 3. So we will try to find out its reverse number, which will be 321. And what we will do, we will do n equal to reverse number, and if it's true we will directly return if it's true or false, because we can see here we have to write a is palindrome function where we will pass int n and we have to return boolean value. It should be true or false. So we have seen one example where we have extracted the number of digits, and then we tried to extract the reverse number as well, right? So what was the example? It was like something like this. Let's say there is number 6336. What will be the opposite, like the reverse number? It will be 6336, right? And what we did earlier, we tried to divide it by 10. So how was it? 6336. So what we did, we divided by 10. So it will be 633. Then again we divided by 10. It will be 63. Then again we divide by 10. So nearby number is 60 and it will be 3. Then again we divide by 10. It will be 0. So that means every iteration we have extracted the last digit. And how we can achieve the last number, how we can achieve the basically the reverse number from it, we try to multiply the reverse number by 10, and we have to add the last digit. So that was the logic. So if we see for this example, let's say we are dividing it by 10, right? So our reverse number is equal to 0 for the first time, right? So what we'll do, we will multiply reverse by 10. So 0 into 10 plus last remaining remainder from the number. So basically what is the remainder from it? 6336 minus 633, it will be 6. So we will put 6 as our first number. Then what happens in this iteration? Our reverse rev number equal to 6. So for this iteration, what will happen? We will take a remainder as 3, right? So 6 into 10 plus 3, it will be 60 plus 3, 63, right? For this number, what will happen? It will be, my remainder is 3. So 63 into 10 plus 3. So it will be 633, right? Then for this iteration, my remainder is 3. So 633 into 10 plus 3, it will be 6336. So this is how we achieve the reverse number, right? So what we want to write is, we will write it here. And also in this particular example, like we are losing our input n, so we will take one copy of it. So let's write one for while loop. What for while, for how many time it will run? It will run for n is greater than 0, right? And we will take a we will take a copy of int copy of n, copy equal to n. We have copied our the input n, right? And after that we'll take int rev number. This is our reverse number equal to 0 for first time, right? Then inside that what we'll do, we will divide our n equal to n by 10, right? It will extract my last number. So what we'll do here, rev number equal to rev number into 10 plus last digit. And how we will get our last digit? We will get our last digit by last digit equal to int last digit equal to n modulus 10. So this will give you remainder. So rev number, this is our reverse number, and at the end what we'll do, we will try to return what? Same condition that we thought about. This is n equal to rev number, n equal to rev number. Okay, so let's try to code this particular example here. First thing, we'll take int copy equal to n, then int rev num equal to 0, then we'll run our while loop, n is greater than 0. After that what we'll do, int last digit. How we find last digit? N modulus 10. So it will give you remainder, which is your last digit. Then rev number equal to rev num into 10, right, plus last digit. After that n equal to n by 10, right, and at the end what we'll do, we will return n equal to rev num. Let's try to run this. Oh, your answer false, expected true. Where it went wrong? So what we are doing, rev number return, right? So in this case it is passing, so 1 2 3 false, right? And this case it is failing. Why it's failing? rev number into 10 plus last digit, so it is right. And last digit n modulus 10, that is also correct. N by 10, that is also correct. And n is greater than 0. Till that time we will run our this thing. So int last digit go to n mod 10, right? So it should be correct. I don't think so we are missing anything here. N equal to n mod 10, that is also right. We are returning n equal to rev number, and let me just print the reverse number once. System dot out dot print, just see what it's giving. We'll try to understand. One to one, it is giving 1 to 1, right? 1 to 1 equal to 1 to 1 should be true. Let me just add one more here. Illegal start of expression. Okay, what we'll do, incorporate three to one is false, right? But for 1 to 1 it should be true, correct? So in this particular case, and now this is also failing because false. Okay, printing should not be there actually. So let me try to rewrite it. Maybe if n equal to rev num then in this case what we will do, we will return true, we will return true, right? And else we will return false. Let me try to rephrase it. It's still returning false. N equal to is correct, right? And not, it should return true, right? Let's see his example, what was given here. So what they have done, they have similarly done that. They have taken a copy of n, yes, and they have revision number, then while, right, n mod 10, and yes, copy, return copy. Sorry, we have lost our n, right? So that is why we are missing our thing. We have taken a copy here, right? So it will return true now. Yeah, yes, it's accepted. And also, like, talking about the time complexity here, it is like we have seen, right, in previous example, it is O of log base 10 n, right? And space is O of 1. So yeah, that's it for now. Thank you.